So that network called DriveNet is running on currently a Titan X. And if somebody can later bring me a Titan X so I can hold up what a Titan X looks like. A Titan X is basically NVIDIA's highest performance GPU that's used in desktop PCs. Running on a Titan X, just now the NVIDIA DriveNet can achieve about 50 frames per second. Now, Mike said that basically it's brute force at the moment, and there's going to be plenty of tuning. On the other hand, we're going to keep making the network more and more robust and arguably more and more deep, and there'll be more and more processing. And so the point is that it takes something like this, like one of the world's highest performance GPUs, to be able to do deep learning at the rates that we're talking about. Now, at the moment, we think that the right answer is to throw a lot of computational horsepower at the problem. And the reason for that is because we're looking for, we're doing R&D at the moment. We're trying to develop a great network. We're trying to discover what deep learning can do, the outer fringes of the possibilities of it. The last thing we want to do is to struggle with the computing resources inside the computer. So we put to task deep learning on a Titan X. I'm going to come back to that in a second, because almost everything I'm going to compare to later to give you a sense of what a PX2 is going to be compared to a Titan X. Okay, so this runs, NVIDIA DriveNet currently runs on, thank you very much, thanks Paul, runs on a Titan X at 50 frames per second. And so this platform is used internally for us to develop our reference neural net, reference self-driving network, perception network, we call it NVIDIA DriveNet. But there's amazing engineers all over the world that are working on the NVIDIA platform. At Audi, Audi is using our NVIDIA GPUs and our NVIDIA platform called Digits and PX for them to do their work around self-learning. This is really an amazing achievement. In just a few hours, the Audi engineers were able to use the NVIDIA platform to train a network that can recognize signs, the German road signs, at a level that beats every hand-coded computer vision approach. In fact, if you look at this, this is the German road signs test, and the #1 score is by the Swiss AI Institute, and Jürgen and his researchers achieved the #1 score on that thing with a deep neural network. What's really amazing is this: the #2 score is human. So the deep neural network is now able to achieve better perception recognition capabilities of road signs than a human can, and completely beat hand-coded computer vision approaches. The folks at Daimler and Mercedes are using the NVIDIA platform for their deep learning work for self-driving cars. And you can see here what they've been able to achieve with deep learning is really quite remarkable. Notice their pixel labeling and their pixel segmentation. It's almost perfect. Every single pixel that's associated with the car, every single pixel is associated with the person, the bicycle, the tree, the building, the road, the sidewalk, done incredibly well. And so this network has been able to essentially pick out what every single pixel is associated with. The folks at ZMP, they're a famous Japanese company who's building a robot taxi that's going to be deployed by the Olympics in 2020. They're using NVIDIA platform for deep learning as well. The folks at BMW are using it not just for self-driving cars, but also for visual quality inspection on their manufacturing lines. Preferred Networks, another Japanese company working on artificial intelligence at a cloud, large global network scale. Their vision is to apply deep learning with all kinds of Internet of Things connected to it, whether it's robots or machines or drones or cars, and to apply deep learning to collect data and make all of these devices and services smarter. Preferred Network is a partner of Panasonic for smart cameras, Fnac for smart robots in manufacturing, and also Toyota. Ford is using our technology for deep learning as well, and they've been able to achieve really quite remarkable results in a very short period of time. But there's so much more to do. There's so much more to do. Not only do we want to be able to recognize objects, we want to be able to recognize circumstances. There are many circumstances that we drive to on a daily basis that we take for granted. There are many roads that we take where there are no road lanes. There are many roads where it's not even clear where the lanes are. And if you take a look at the lanes on that snowy road, it's kind of hard to tell exactly where the lanes are and where you should keep. Should you follow the lanes or should you follow the cars? There are all kinds of conditions by which surprising circumstances happen. This example of the bicyclist that comes sideways on the car. Every bus is not the same. There are passenger buses, public transit buses, where it's okay to just drive by. School buses, you should stop. Every truck is not a truck. Some trucks are ambulances, and you should pull aside. All of these different scenarios, not only do you have to recognize what they are, but understand the circumstances, the special circumstances. These are all trainable things. So whereas today we're focused on training detection, perception, very shortly we're going to move towards training for recognizing circumstances. So that's the first part. The first part is the platform by which we can train our networks to create that deep neural net that we will ultimately run on Drive PX2. Now, before I show you the next part, Drive PX2 is a computer, it's a supercomputer, and has an enormous amount of processing capability. But one of the great challenges of a self-driving car, with all of these streaming sensor information and the vast amount of processing that we have to do, it is the ultimate system software challenge. This is the union of real-time computer graphics challenges and supercomputing work coming together in one. The amount of system software that we've been able to leverage as a result of our 2 decades of work around real-time computer graphics and all of the work that we've done here on deep learning coming together in a body of work we call DriveWorks. DriveWorks, the operating system, the algorithms, the middleware, the streaming pipelines, all of that comes together, has to run on this incredible processor, incredible computing platform called Drive PX2. Lots of system software, lots of algorithms, lots of engineers work on this. Several thousand man-years of work have come together to make DriveWorks possible. Okay, so now we're going to show you what DriveWorks can do.